Hello, welcome. Today we're going to be learning about the Saga design pattern and how it helps us with coordinating complex processes. So first, let's start with the technical definition. The Saga pattern is a design pattern used to coordinate complex and long-running processes, ensuring consistency and fault tolerance. Let's look at an example. Imagine you're organizing a party with lots of activities happening simultaneously. You want to make sure everything goes smoothly, but you also want to handle failures gracefully. The Saga pattern is like having a script for your party. You break down the different activities into smaller steps, and if something goes wrong, you have instructions on how to fix it or roll back the changes. It's like having a backup plan for your party so you can adapt and recover if things don't go as expected. So let's look at some of the components that we have with the Saga design pattern. First, we have the orchestrator, which controls the execution flow and coordinates the Saga steps. Then we have the steps, which are individual units of work within the Saga, representing specific actions or operations. Then we have our compensating actions. These define for each step to reverse the changes made in case of failure. Let's look at an example use case. Say we have order and payment processing. Imagine an e-commerce system where you need to handle order placement and payment processing together. The Saga pattern helps coordinate these steps to ensure that a payment is only made if an order is created. If the payment fails, the order creation is canceled. What are the benefits of the Saga design pattern? First, we have fault tolerance. Sagas provide fault tolerance by allowing partial rollbacks and ensuring that the system remains consistent. Modularity. Steps and compensating actions can be developed and tested independently, promoting modular and reusable code. Adaptability. The Saga allows for flexibility in handling failures, enabling you to find custom recovery and compensation strategies. In conclusion, the Saga pattern is a powerful approach for managing complex and long-running processes, guaranteeing consistency and fault tolerance. By breaking down processes into smaller steps and defining compensating actions, Sagas enable adaptability and recovery even in the face of failures. And with that, let's take a look at our code example here. So we have a simple TypeScript application here. And what's important for our state is our app state right here. You see that we have an order and a payment status, which can be in the state idle, pending, success, or failure. We have a reducer that controls how our state changes depending on the actions that are launched. We have our initial state, we create our store, and we set up a subscriber to render out each change the state makes along the process. And then we have our saga. So to define our saga and explain it a little bit deeper, let's start from the bottom. So we can see that we have this generator that we pass to our run saga function along with our stored dispatch function. Now our generator is our root saga. And a generator basically allows us to use this yield function, and each yield can be seen as a step in our saga. And what run saga does is it takes each step and it recursively launches each stage of the step with our own custom defined logic until the results are done and there are no more steps. We can take a look at our root saga and see we are calling our saga orchestration. So this is our orchestrator and what calls our sagas. We're giving it a default action here with a payload with our order ID and a type of create order. So when we come over here to our saga orchestration, we see that we are starting with our order saga. Once that succeeds, we are moving into our payment saga. And once that succeeds, we are launching the final step of Saga success. If any issues happen during this phase, we catch those errors and we gracefully handle them with yielding a step of Saga failure for the end and a payload letting us know what happened. So let's start with the order saga. So when we check out the order saga, we see that our saga orchestrator starts with an action for create order. And we pass that action to our order saga. And here you see we have a case for create order. So in the event of create order, we yield a step that returns an action of perform order, and it has an operation of create. Now we can go check our run saga function and see that indeed we have a perform order case here. And in the event that our operation is create, we dispatch our create order action with our payload. Then we move to the next step in our order saga after our switch is done, which is order success. If anything happens in here, we catch those errors and handle them just like before with our order failure step. Now we move to the payment saga. And when we call the payment saga, you can see that we have a default type of make payment. We have a case for make payment in our payment saga where we yield a step with an action of type perform payment and an operation of make. So when we check our run saga, we see we have a case for perform payment and a case for our make operation where we dispatch make payment. Then we go to the next step, which is make payment success. And like before, if there are any errors, we yield make payment failure and handle those errors gracefully. And then after our sagas have completed and our payment saga has succeeded, we can yield a type of saga success to let us ourselves know that our saga orchestration has completed, and again, handling errors gracefully. So let's take a look at our reducer and see how the state is changing as things happen. So in our initial state, our order is null and our payment status is idle. When we call our create order, which is the first case that we run, we set our order, we give it the order ID in our payload, and we change the status to created. Then we follow to make a payment, where we change the payment status from idle to pending. And in the event of make a payment success, we change our order status from created to completed, and our payment status from pending to success. And in the event of failure, we change order status to cancel and payment status to failure. So that is it. Let's run our code and look at what we have. So you can see the same steps that I have described have logged out. We start our orchestration with our order saga. We dispatch create order. Our status is created and our payment status is idle. And then our order succeeds, allowing us to end our order saga and begin the payment saga. We make a payment. In the current state, our order status is created and our payment status has been changed from idle to pending. And we launch payment success. So our status is changed from created to completed on our order, and our payment status is changed from pending to success. And our payment saga ends, and we dispatch our saga success, and we end with the current state after our saga has completed. Thank you so much for watching. I hope you learned something, and I look forward to seeing you again.